Hello everyone, welcome back to our channel Astrophysics Pinto. And you know what, today I just woke up and I was thinking why not making a video about binomial expansion. Many of you have been asking me what is it about, what is binomial expansion. Well, what we mean by binomial expansion is when you have two variables, let's say you have x plus y, you have x plus y, and then this x plus y, the sum of these two, you take it power something, let's say power n. In this case, n can be 1, 2, 3, 4, 5, infinity, any number. So let me consider just some few expansions. If you have, let's say, if you have x plus y, let's say you have it power 0. Now you know that any number power 0 you get 1. Okay, now let me call it equation number 1. It's going to be my first equation. Now let's say what do we have? X plus y. Now let's say x plus y power 1. So power 1, it means that I have x plus y. Any number power 1, you get the same number. Let me call it equation number 2. Equation number 2. And now let's say what we have x plus y squared. Now, when I say the square, means that the same numbers be multiplied twice. So I have x plus y times x plus y. Now, this is what we call x plus y squared. Now, if you expand this one, you're going to get x squared plus 2xy plus y squared. Now guys, I like you to look at this certain pattern that is being formed here. We have x plus y power 0, we get 1. Then we have x plus y power 1, we get x plus y. So, and then we have x plus y squared, is just x squared plus 2xy plus y squared. Now, what I like you to look at is that it seems that whenever you increase this power, for the side of x, it decreases by 1. You can see here that I have x squared here. I have x squared, and then now the x is being decreased by 1, so it becomes x squared, then becomes x. And that the certain value of y increases by 1. Here at this side is like the same if I have y power 0. Y power 0. And then here I have y power 1, y squared. So it implies that if I have, let's say, x plus y power n, so it is going to be x power n, okay? Then we have plus a certain number here. I will leave this space. This is not 0. This means that there is a certain number here that I will have to put here. And then x is going to decrease by 1. So let me put x and minus 1. If the value of y increases by 1, so let me put it y power 1. And then if I keep on, let's say I keep on, here there should be another number, and we shall discuss about these numbers that belong here. So I have x, and guess what? N minus 2. And then I have y squared. Until we go on, until we reach to y power n. So this is basically a very simplified of the binomial theorem. And I will explain to you what numbers should we put there in those blanks that we have created. So guys, if we want to know the number that belongs to the blanks that we left behind, so we have to understand the combinatory formula. Combinatory formula is given by n combinatory of r. And I should make a video about this in another time. So n combinatory r is given by the formula of n factorial. I think that you know factorial. N factorial over n minus r factorial times r factorial. Now this shows me something. Let me explain to you something. N is the same n as in our expansion. So let me just write it here. Have x plus y power n. So and it is defined as x power n plus n combinatorial of 1. Then we have x and minus 1 as we discussed before. I have y power 1. Then I have a plus n combinatorial 2. Then I have x n minus 2. then I have y squared, and then I go on, there should be a plus here, I go on until I reach to y power n. Now, of course, we can develop this to another stage. So let's first define what is n combinatorial 1. So as I said before, this is going to be n factorial over n minus 1. Then we have factorial times 1 factorial. Now, what happens here is that we have to define what is n factorial. N factorial is the same of saying n times n minus 1, and then we have factorial. I think that you know this. So I just say n minus 1 factorial from its own definition, and I divide it by n minus 1 factorial. Now, this and this will die. I just remain with, let's say, n of 1 is equals to n. And now let's find what we mean by n combinatorial 2. N combinatorial 2 is just n factorial over n minus 2, which is r in this case, factorial. Then we say times 2 factorial. So we can define again what is n factorial. So let me just put here n factorial is the same as saying n times n minus 1, and then let me just move this one a bit to this side, n minus 1, and then I have n minus 2 factorial by its own definition. So you can just proceed here. So it is going to be n, let's say n minus 1 multiplied by n minus 2 factorial over I say n minus 2 factorial times 2 factorial. So this n minus 2 factorial, will die. I remain with n, then I say n minus 1 over 2 factorial. And this is n combinatorial 2. Hence, we can write again this equation by using what we have discussed before. So if I expand, I get x power n, as I said before, plus n combinatorial 1, which is n. Then I have x n minus 1, and then I say y power 1. I can continue here by saying n combinatorial 2, we discussed that it is n. Then I have n minus 1, and say over 2 factorial times x n minus 2. Then I have y squared. And I may proceed with more of them. Let me just write some of them else here. And I think that according to what I have shown you, you can derive. So it is just n minus 1. It becomes a little bit longer, n minus 2, over, guess what, 3 factorial. Yeah, it is 3 factorial. And then I have x n minus 3. Then I have y cubic. And then you can proceed, plus you go on until you get to y power n. And this is what we call the binomial theorem. Guys, I really enjoyed making this video. If you have any question, I was forgetting. Let me make some examples here. For example, I think you remember the expansion of x plus y power 2. Okay, we know that it is x squared plus 2xy plus y squared. We have discussed it before. Now let me solve by using binomial expansion. We have x power n. X power n is 2 plus. Remember, there is an n here. So what is n? N is 2. X decreases by 1. 2 minus 1, we get 1. And y increases by 1, so I have 1. Plus until we reach to the last term, which is y power n. So it is just y squared. Now you may try it with let's say x plus y cubic. Okay. Now x plus y cubic, if we say it is x power n in our case is 3. Okay, plus n remains the same here. So I have n is how much? Is 3. X decreases by 1, so it becomes 2, and also y increases by 1, so it remains 3, plus n, 3 combinatorial 2 is it is still 3, so I have 3 You can also plug it into the calculator. It gives you the answer. 3 combinatorial 2 is the sum of 3 combinatorial 1. So it is 3. X decreases by 1, so I have 2 minus 1, I get power 1. And y increases by 1, so it becomes y squared. Okay? Until we reach 2 plus y power n, which is cubic. And this is this function of x plus y cubic. And now you may try it with many more, like you can try it with x plus y power, let's say power 20, power 30, as much as you can.